Dynamic programming. It is a design technique wherein you can solve a problem which is defined by or formulated as recurrences with overlapping subinstances. This is invented by American mathematician Richard Bellman in 1950. Dynamic programming was used to solve optimization problems. Later, it is used by computer science subjects. Programming here means planning. The main idea behind dynamic programming is you are required to set up a recurrence relation, solve smaller instance only once, record solutions in a table, then finally extract solution to the initial instance from the table. So this dynamic programming is more suitable for the problems involving overlapping subproblems. So let me repeat it once again. This dynamic programming is more suitable for the problems which is defined by recurrence relation, that too overlapping, which involves overlapping subproblems. So recurrence related overlapping subproblems can be solved by using dynamic programming approach. So the main idea here is you are required to set up a recurrence relation, solve smaller instance once, record solutions in a table, finally extract solution to the initial instance from the table. Next, we will see how you can solve Fibonacci numbers by using dynamic programming. Already you know the recursive definition for finding the n Fibonacci number, that is Fn equal to Fn minus 1 plus Fn minus 2. And the base conditions are F0 equal to 0 and F1 equal to 1. In order to find out the n Fibonacci number, in recursive call, it will be called for Fn, and then it will be called for Fn minus 1, Fn minus 2. Finally, it will be terminated with F0 or F1. So this is called top-down approach. When you do like this, you will be having many overlapping subproblems. So you are solving these subproblems more than once. For example, here, when you want to find out fifth Fibonacci number, it will be called for F4 and F3. In turn, F4 called for F3 and F2, and F3 is called for F2 and F1. So like this, it will be called more than once. F2 is called more than once, F3 is called more than once. So like this, you are solving smaller subinstances more than once. So this kind of recurrence related overlapping subproblems can be solved by using dynamic programming. Here let me explain how you are finding the solution here. In order to find out F2, F1 plus F0, that is equal to 1. Again, F3 can be found like this, F2 plus F1, that is equal to 2, and F4 is 2 plus 1, 3, and F5, 3 plus 2, so it's equal to 5. This is how it will backtrack and give the value for the nth Fibonacci number. This is normal recursive tree call. So we'll see how we can find the solution by using dynamic programming. So in dynamic programming, instead of using top-down approach, we'll use bottom-up approach here and record the values in the table. And whenever you want to find out the solution for larger instance, retrieve the values from the table and substitute. With that, you will be getting the solution for the larger instance. So you can avoid solving the subinstances more than once. So we'll see how this fifth Fibonacci number can be found by dynamic programming approach. So first record values F0 and F1. Then how do you find F2? F2 can be found by F1 plus F0. So 1 plus 0 is 1. then F3 can be calculated by F2 plus F1, that is 1 plus 1, 2. Then F4 can be calculated from previous column plus previous to previous column, that is 2 plus 1 equal to 3. Finally, F5 can be calculated by using previous column value is 3 plus 2, that is equal to 5. This is what dynamic programming approach here. Okay, so the dynamic programming approach is most suitable for the problems which can be solved by recurrences, that is recurrence related overlapping subproblems can be solved by using dynamic programming. Here you are not solving more than once. Here subproblems are solved only once, and in order to find out the larger subinstance, you can make use of the values which is already found for the smaller instance and which is recorded in the table. So this is how you can avoid calculating solution for the smaller instance more than once. Instead of finding the solution more than once, you are finding only once. So finally, we'll see the examples for dynamic programming. That is, to compute binomial coefficient, we can use dynamic programming, longest common subsequence, then Warshall's algorithm to find transitive closure of a graph, then Flight's algorithm to find all pair shortest path, and to construct an optimal binary search tree, and some optimization problems like traveling salesman problem, knapsack problem can be solved by using dynamic programming approach.